Hey everybody, here are the notes for homework 10, part 1, domain and range, although this part 1 is just going to be domain and then part 2 will be range. So there are 3 general rules for domain. And when we talk about domain, what we're really saying is for some function, we want to know what values x is allowed to be. So we want to make sure that x isn't anything that makes the function undefined in some way. So there's 3 kind of ways typically that the function might end up being undefined. One way, the first way, is that if f of x equals some sort of fraction or quotient type of thing, we don't want the denominator to equal 0 because dividing by 0 is undefined. So if f of x equals whatever on top over some stuff, then we want to exclude the stuff. So in other words, we're going to set the stuff equal to 0. In fact, I should really say, pardon me, exclude stuff equal to 0. Right? We don't want the stuff to ever equal to 0. So in this example here, if I wanted to find the domain of f of x equal to 3x plus 1 divided by x minus 2, I want to make sure that I exclude x minus 2 equal to 0. In other words, if I add 2 to both sides, I'm going to exclude x equal to 2. The way I write the domain for that is by writing it using interval notation. I want everything except for 2. You can draw a little number line if you like. There's 2. I don't want 2. I want everything over here. I want everything over here. So my interval notation is going to be everything from negative infinity to 2 with the parentheses to exclude the 2, union everything from 2 to infinity. So this means we're getting everything close to 2, like 2.1, 2.2, 2.0000001. Over on this side, we're getting everything close to 2 that's less than 2, like 1.999. So you want every single possible number except for just 2. So that's how we write that. That would be the domain of this example function, 3x plus 1 over x minus 2. Every other x value is fine except for 2. Second type of thing where you might have a domain issue, or what I'd like to say is a domain restriction, right? You're not allowed to have every x value necessarily, is when you have f of x equal to the square root of some stuff. If that's the case, we're going to set the stuff to be greater than or equal to 0. Because you can certainly take the square root of 0, it's 0, and you can take the square root of any positive number, but we can't take the square root of a negative number. So for example, if I want to find the domain of f of x equal to the square root of 3x plus 12, I would set the insides, the stuff, 3x plus 12, to be greater than or equal to 0. And then depending on the complexity of the problem, if this thing on the left-hand side looks like it's linear, meaning you only have x to the first power, you don't have any other powers of x, we can usually just isolate x. If it's nonlinear, like x squared or x cubed, we often end up having to factor this. So here, I'm going to subtract 12 from both sides. So 3x is bigger than or equal to negative 12, and then divide both sides by 3. So that x is bigger than or equal to negative 4. On the number line, again, you don't have to draw the number line. I just like to draw because I think it makes it easier to see what's going on. I'm only putting the numbers that matter. I don't care about 0. 0 is not important here. I just care about negative 4. I want to include negative 4. And I want everything where x is bigger than or equal to negative 4. So I want everything to the right of negative 4. All those numbers to the right, like negative 3 or negative pi or 2 or e or pi to the 7th power or 1,000, all those numbers are bigger than negative 4. So my domain here would be negative 4 with a bracket because I want to include that number all the way to infinity. Thirdly, and we won't encounter this very much in this homework assignment, but it seemed like it should cover all the usual things for domain here. So if your function is a logarithm of some stuff, then we're going to set that stuff to be strictly greater than 0. It's very similar to the square root kind of thing. You can take the square root of 0 and any positive number. You can take the logarithm of any positive number, but you can't take the log of 0, and you can't take a log of a negative number. So you set the argument or the stuff to be strictly greater than 0. And then it works out pretty much the same sort of way. If I was trying to find the domain of f of x equal to the natural log of 2x minus 10, it doesn't matter what the base is. The base could be e or 10 or 5 or 7 or whatever. But if we're trying to find the domain of some log, natural log in this case, of some argument, 2x minus 10, we're going to set the stuff, 2x minus 10, to be greater than 0. Notice I'm not setting the whole function to be greater than 0, right? I didn't write the natural log of 2x minus 10 is greater than 0. Just like up here, I didn't write the square root of 3x plus 12 is greater than or equal to 0. I'm just setting the inside part to be either bigger than or equal to 0 in this case, or strictly greater than 0 in this case. And then same kind of deal. Add 10 to both sides, divide both sides by 2. You get x is bigger than 5. So again, not necessary to draw the number line here, but I want to exclude 5. We use an open circle to exclude, a closed circle to include. And then I want everything to the right of 5 because I want x to be bigger than 5. So here my domain would be everything from 5 exclusive to infinity. It is very common that for fractional kinds of things like this, you're just usually removing a few points. You're getting everything except for 2, or maybe everything except for 2 and 3 and 7. Whereas with square roots and logarithms, you're usually excluding an entire side of the number line. So I didn't get this whole entire left side here. I didn't get this whole entire left side here. So that's kind of something I've noticed is the main difference between these types of functions and these types of functions. Cool. That's pretty much all there is to say about domain, honestly. Like, we're going to do some more complicated problems, but these are the 3 things you should know about domain. If I ask you what's the domain of this function, you should ask yourself, is there a fraction? Great. Figure out where the denominator is equal to 0, remove those points. Is there a square root or actually any even root, like a 4th root or a 6th root or an 8th root? If there's an even root, then we have to have the insides to be greater than or equal to 0. And finally, if there's a logarithm, the insides have to be strictly greater than 0. Those are the only 3 things you really need to look for when we're talking about domain. So if you don't see any of those hallmarks, you can typically say that the domain of the function is all real numbers. Okay, so here's some examples. We're going to find the domain of f of x equal to x squared minus 9 over x squared minus 5x. I think I should zoom in a little bit just because I think that'll make it easier to see what's going on. And also, I've got room. Let's zoom in just a tiny bit. That's a little bit better. Cool. All right, so I feel like my camera angle is not 100% excellent here. Okay, well, that'll be fine. So find the domain of this function here. So we're going to set, since it's a rational or a quotient kind of thing, we're going to set the denominator, x squared minus 5x minus 6 equal to 0. And we're going to exclude those solutions to this equation. So I'm going to factor this, right? It's nonlinear. It's not just x to the first. There is an x to the first right there, but it's also got an x squared. So for any other powers of x, we don't want to try and solve for x. We want to factor. This factors as x minus 6 times x plus 1 still equals 0. Because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So then, if you set this factor equal to 0, you're going to get x equal to 6. If you set that factor equal to 0, you're going to get x equal to negative 1. So those are the 2 values we want to exclude, because those are the 2 values that make the denominator equal to 0, and we can't divide by 0. Again, not necessary to draw the number line. I just like to make sure if you do draw the number line, you put the numbers in the correct order, meaning bigger things on the right, smaller things on the left, negative things further left, more negative things even further left. And we don't want to include any of these points, but then we do want everything else. So all of this, all of this, all of this. The way we write that, and you always want to write it kind of from left to right. So starting over here on the very left at negative infinity, we want everything from negative infinity up to almost negative 1, but we want to exclude negative 1, so we use a parentheses. Union everything between negative 1 and positive 6. Union everything bigger than 6. Something noteworthy here, negative infinity and infinity always get a parentheses because they're not actually real numbers, so we can't actually ever include them. We're just saying we go further left and further right. So there's our domain. That's it. That's all there is to it. We didn't even think about what was going on in the numerator. I will point out, if we had factored this numerator and stuff had canceled, it doesn't here, but I'm just saying if it had, we would definitely want to look at the domain before we did any simplification. You always want to look at the original function before you, when you're thinking about the domain, you always want to look at the original function before you've done any simplification. Great. Let's look at the next one. So the next one says, find the domain of the square root of x cubed minus 16x. So since it's a square root or any even root, we're just going to start by setting the insides to be greater than or equal to 0. And now we're going to factor. So first I can see that both of these terms have an x. I'm going to factor out an x. I'm left with x squared minus 16. And then I'm going to factor this further. We should always factor this as much as possible. X squared minus 16 factors as x minus 4 times x plus 4. Now, in this case, where I'm trying to solve an inequality, I definitely do need to use the number line. I'll point out that the zeros, the things that make this thing equal to 0, are x equal to 0, x equal to positive 4, x equal to negative 4. Yes, I'm skipping the step of setting each factor equal to 0, but if you set each factor equal to 0, if you set x equal to 0, you get 0. If you set x minus 4 equal to 0, you get x equal to positive 4. If you set x plus 4 equal to 0, you get x equal to negative 4. You can skip that step, but it's also fine to write it down. So I'm going to put those numbers on my number line in the correct order. So 4 should be to the right, 0 to the middle, negative 4 to the left. The reason I'm writing these down is because those are the values that make this equal to 0. Those are the only places where you can change signs of this quantity. So, for example, if you pick a number bigger than 4, like 5, and plug it in, you get 5 times 1 times 9. I actually don't care what the numbers are. I know if I plug in 5 here, it's a positive times a positive times a positive. And a positive times a positive times a positive is positive. And then what I want to point out is it didn't matter if we picked 5 or 500. If I plug in 500, it's still positive. 500 minus 4 is positive. 500 plus 4 is still positive. So any number bigger than 4 is going to make each one of these pieces positive. Because a number bigger than 4 minus 4 is positive. A number bigger than 4 plus 4 is positive. A number bigger than 4 itself is positive. So you can just pick any number. And that's why but then we have to do the same thing for these other intervals. So we look between 0 and 4. I pick the number 1. That part's positive. 1 minus 4 is negative. 1 plus 4 is positive. And a positive times a negative times a positive overall is negative. You can actually find the values if you want to. Like if you actually plug in 1, you get 1 times negative 3 times 5, which is negative 15. But you don't need to find the number. You just need to find the sign. Looking over here, I pick a number like negative 1. I get negative times a positive, right? Because negative 1 plus 4 is positive. So overall the sign is positive. And finally, plug something like negative 5, you get a negative times a negative times a negative, which overall is negative. I want to include the endpoints here because I want the values that make this equal to 0 because it's a greater than or equal to 0 inequality. So I want to include each of these endpoints. And then I want the parts that make it bigger than 0. So I want the positive parts. So I want all of this, and I want all of this. I don't want anything between 0 and 4. I don't want anything less than negative 4. For example, if I plugged in 1 back to the original function, just to show you that I don't want 1, f of 1 would be the square root of 1 cubed, which is 1 minus 16. That's the square root of negative 15. That's not real. I don't want that. Similarly, if I pick negative 5, f of negative 5 would be the square root of negative 5 cubed, which is negative 125. And 16 times negative 5 is 8 well, negative 16 times negative 5 is positive 80. And negative 125 plus 80 is negative 45. Again, I can't take the square root of a negative number. So those two values should not be in my domain because I can't evaluate the function there and get a real result. So here our domain is all the things I've scribbled in here. It's everything from negative 4 to 0 with brackets because I want to include those points, union 4 to infinity. Just to point out, the endpoints are good here. If you plug in 4, f of 4 is the square root of 4 cubed, which is 64, minus 16 times 4, which is also 64. And that's the square root of 0. And the square root of 0 is a nice real number. It is 0. So we're totally good to go here. That's our domain. A few more examples. Find the domain of f of x equal to the square root of x plus 7 divided by x minus 1. So this function has two things we need to look at. We have both a fraction and a square root or an even root. I'm going to look at, it doesn't actually matter which part you do first, really. I'm going to look at the denominator part first. So I want to set, I like to just write exclude. Actually, I really like the word exclude. I want to exclude where x minus 1 is equal to 0. Or in other words, I want to exclude x equal to 1. Great. So I don't want x equal to 1. And then I also need to, and I know that looks terrible, sorry. I need to set the stuff inside the square root to be to be greater than or equal to 0. So in this case, that's going to end up being just x bigger than or equal to negative 7. Personally, I find it easiest to figure out what I want to do by drawing things on the number line. The number line is your friend here. Use the number line. So I put the important numbers on the number line. So I've got negative 7 over here. I've got positive 1 over here. I don't want positive 1. But I do want everything bigger than or equal to, meaning to the right of -7, including -7. So I want -7, and I want everything over here. I don't want 1. I want everything over here. So 2 would be totally fine, right? 2 plus 7 is 9, square root of 9 is 3, 2 minus 1 is 1. As long as the denominator isn't 0, you're totally safe. But -8 wouldn't be okay because even though -8 minus 1 is totally fine to divide by, it'd be -9. -8 plus 7 is -1, and we can't take the square root of -1. So here our domain would look like everything from bracket -7 to +1 with a parentheses to exclude the 1. And then when we have like more than one interval that we have to connect, I know I didn't say this previously, we use this U symbol for union. And then we want everything from 1 to infinity, excluding 1. That's it. Okay, now we're going to look at how this next one's a little bit different. So this next fraction looks very similar, except now it's the square root of the entire fraction, x plus 7 over x minus 1. So it's actually going to work out a little bit differently. I still want to start the same way. I still have a denominator, so I definitely want to exclude x equal to 1, just like last time. But now I'm going to set x plus 7 over x minus 1 to be greater than or equal to 0. And honestly, the best way to solve this is to use the number line. So before I was saying how like if you multiply a bunch of things together, we just care about the signs. That's also true when we divide things. So what I'm really going to do here is I'm just going to look at the number line. I'll put my important numbers on there again. So my important numbers are still -7 and 1. -7 because if you plug in -7, that will make this whole thing equal to 0. You get 0 over -8. And 1 because although 1 doesn't make the whole thing 0, it doesn't make the whole thing undefined. So whenever you're doing this number line kind of thing, you always want to include all the points on the number line that make your expression either equal to 0 or undefined, because that's where we can change signs. So I've got my +1, I've got my -7. I already know I don't want to include +1 because it makes the whole thing undefined. I do want to include -7 because it makes the whole thing equal to 0. And square root of 0 is totally legit. So I'm just going to start picking points. Pick a 2. 2 plus 7 is 9. 2 minus 1 is 1. A positive number. I should have just said 2 plus 7 is positive. 2 minus 1 is positive. And a positive divided by a positive is positive. In between -7 and 1, if I can pick 0, I always pick 0. So I plug in 0. 0 plus 7 is positive. 0 minus 1 is negative. And a positive divided by a negative is negative. Right? You'd literally have 7 divided by -1, which is -7. I can't take the square root of -7. So 0 is no good. Neither is -3, right? If you plug in -3, -3 plus 7 is 4. -3 minus 1 is -4. And 4 divided by -4 is -1. And I can't take the square root of -1. Over here, picking something less than -7, like -8. -8 plus 7 is -1. -8 minus 1 is negative something. And a negative divided by a negative is positive. Fun fact, when you're doing these kind of things, if you have an odd number of negative things multiplied or divided together, it's going to be negative overall. If you have an even number of negative things multiplied or divided together, it's going to be positive overall. To here, I still want the positive parts because it's a greater than or equal to. You should pay attention to this, right? Occasionally later on, we might have an inequality where it's less than 0, and then you want the negative parts. But here, it's going to be greater than or equal to 0. So I want the positive parts and none of the negative parts. So here, my domain is going to be everything from -infinity to -7 with a bracket, union, parentheses 1 to infinity. Yes, it's okay that x is negative because when you plug in some negative numbers for x, this whole quantity ends up being positive. And we just need to take the square root of a positive number. It doesn't mean that x has to be positive itself necessarily. All right, a few more examples. Ooh, I did include a log one just because I thought it was worthwhile. So here we want to find the domain. Excuse me. Goodness gracious. We want to find the domain of f of x equal to x squared plus x plus 1 over 2 minus log of x. So we can kind of just ignore the numerator completely. I'm going to focus on the log of x for a second. I know that for the log of x here, we need the insides, just the x, to be greater than 0. Okay, well, that's just everything bigger than 0. That's for the log of x. But then we also need our denominator to not equal 0. So we want to exclude I should have just said set here really, but we want to exclude 2 minus log of x equal to 0. Let's solve this equation. So I want to point out that when I solve this equation, I would rather not do it this way. I would rather, so I know most people would probably say, let's subtract 2 from both sides. So negative log of x equal to -2, and then multiply both sides by -1. You get log of x equal to +2. I would rather just add log of x to both sides and get 2 equal to log of x. To me, that feels like less steps to get to essentially the same place. It doesn't matter if I write it this way or this way. That's the same equation. Either way, that's a log base 10. So either way, I'm going to have that 10 raised to the second power is equal to x. So I want to make sure I exclude x equal to 100. Because if x is 100, log of 100 is 2, and 2 minus 2 is 0, and we can't divide by 0. So looking at the number line, I have 0 and I have 100. I want x to be greater than 0. I don't want to include 0, but then I don't want x to equal 100. So I want everything on the right side of 0. I definitely don't want anything negative because we can't take the log of a negative number. So here my domain is going to be everything from 0 exclusive to 100 exclusive, union 100 exclusive to infinity. We don't go to like 99 and 101 because we still have to get all the numbers that are right up to 100. So like we need 99.8, 99.9, 99.99999, and so on and so on and so on. So every number that's super close to 100, just not 100 itself. Okay, let's look at this next one. Find the domain of g of x equal to the fifth root of x plus 6 over x squared plus 7. So I will point out here that this fifth root doesn't have any domain restrictions. You can take the fifth root of a negative number or a positive number. You can take the fifth root of, or I should say, you can take an odd root of any type of number, positive or negative. Just for example here, if x were equal to, I'm going to cherry pick a number here. If x, I'm actually do two numbers. If x were equal to -5, I should just say g of -5 would be the fifth root of, I meant to do -7, sorry. -7, apologies, it's terrible. If I plug in -7 plus 6 is -1, and -7 squared plus 7. The fifth root of -1 is -1 because -1 times -1 times -1 times -1 times -1 5 times is -1. That's going to be -1 over something like 49 plus 7, which is 56. But the point is, it's a real number. Similarly, if I did g of, let's see, I want to do -38. I'm just pointing out that you can take a fifth root of a negative number. -38 plus 6 is -32. I don't care about the denominator here. It's something gross, but real. The fifth root of -32 is -2. So you get -2 over something gross. But the point is, that's a real thing. You have -2 over a big number. It's a real number. You can always take an odd root of any sort of input, positive or negative or 0. Okay, so we don't have to worry about that, but we do need to worry about where the denominator might be 0. So we're going to set, we want to set / exclude. I like to say exclude is really the word I like for excluding the denominator equal to 0. X squared plus 7 equal to 0. And then we need to be careful here because if you try to solve this, you get x squared equal to -7, and that should start ringing some alarm bells because we can't square a number that's real and get a negative result. If you keep going further, you're going to get x equal to plus or minus the square root of -7, but square root of -7 is not real. So there's no solutions to this equation, which means there's nothing to exclude. So the odd root here didn't give us any domain restrictions, and the denominator here, since the denominator is always already greater than or equal to 0, actually just say, since its denominator is already greater than or equal to 7 for any value of x you pick, then you're not going to have anything that you can't have in your domain. So here our domain is all real numbers, everything from -infinity to infinity. And that's going to happen sometimes. I'll say particularly, if your denominator is like x to an even power plus some number, that's never going to be able to equal to 0 because x to an even power is already always greater than or equal to 0. And then if you add something onto it, it's going to be greater than or equal to whatever you have added on. All right, almost done here. I think this is the last page before, yeah, cool. Oh, I think I had one more example I wanted to throw in. I might have to throw in an extra example because there's one more thing I want to make sure you all see. So unlike the previous one, this one definitely has some domain restrictions. So I see three things actually. So first of all, I see this denominator x, so that x can't be 0. Then I see my other denominator here, this denominator also can't be 0. So I also need to say 1 minus 4 over x better not be 0. I don't usually like to write not equal 0, so I'm just going to say it's equal to 0, and then I'm going to try and solve for x. I'm going to add 4 over x to both sides. Multiply both sides by x. X times 1 is x, so x equals 4. So I want to exclude x equal to 4. So those are both numbers I don't want. And then I also have a square root, an even root on top, so I need to set the insides of that root to set x plus 3 to be greater than or equal to 0. So x greater than or equal to -3. The easiest way to figure out what my interval notation is going to be is to write it on the number line. So my important numbers are -3, 0, and 4. I want everything bigger than or equal to -3. And I want to include the -3. I want everything to the right because that's the bigger side. So I don't want any of this stuff to the left. And then I don't want 0. And I don't want 4. But I want everything else. So it looks like my interval notation here for my domain is going to be everything from bracket -3 to 0 with the parentheses, union 0 to 4, both with parentheses, union 4 to infinity, both with parentheses. Okay. I got one more here, and then I have one more I'm going to make up because there's one more thing I want to make sure you see. So find the domain and range of x squared minus 25 over x minus 5. So this one does have a range question as well. We're getting into the range bit. Let's talk about domain first. The domain, well, again, we're just going to exclude where the denominator is 0. So we want to exclude where x minus 5 equals 0. In other words, where x is equal to 5. Excuse me. And then, so our domain here would be everything but 5. -infinity to 5, union 5 to infinity. The range requires a bit more work. So here, if we simplify this, and we could graph it, I don't really want to graph it. So for the range, let's think about what our function is. Well, f of x equal to x squared minus 25 over x minus 5. The x squared minus 25 does factor. So we really have the f of x is equal to x minus 5 times x plus 5 over x minus 5. And then the x minus 5s can cancel. Now it's really, really important to remember that even though we've canceled these, it doesn't change what the domain is. So our function is f of x equals x plus 5, but we have to remember that x is not allowed to be 5. So this is a straight line, has a slope of 1, has a y-intercept of 5. And most straight lines, unless they're horizontal, get every y value, right? If you just think about drawing a straight line here, I'm going to draw it kind of not perfectly well. If my straight line looks like this, right? Sorry, I should back up a little bit. When I talk about domain, it's all the possible x values of a function. When I talk about range, it's all the possible outputs or y values or function values. So here, a line that's either increasing or decreasing, has a positive slope or a negative slope, is going to get every y value, except for this one, because we're missing when x is equal to 5. So if x is equal to 5, or we're allowed to be 5, your y value would be 5 plus 5, right? If we could find it, f of 5 would be 5 plus 5, which would be 10. So we're missing the point. Ha 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 ha. We're not really missing the point, but we know the point is excluded from the graph. The x value is 5, the y value is 10. So 5 is missing from the domain, and 10 is missing from the range. So the range here, I know I said I didn't want to graph it, and I totally graphed it. The range is everything except for 10. So everything from -infinity to 10, exclusive union 10 to infinity. So that's what happens with range. Well, sometimes with range is that for things like this, you have to make sure that you're like, oh, well, my graph kind of looks like that, but I know that x isn't allowed to be that. So then I find the corresponding value that y isn't allowed to be. All right, one more quick example here because there's one more thing I want to make sure you all see. We'll get to this. We'll get to this in the next video. So this would be, let's see, that was number 8. So here's number 9. Let me throw one more thing at you because there's something kind of funny that happens occasionally. So let's say our function is the square root of, let me think something real quick here. Sure. let's say it's, yeah, x to the fourth minus 3x cubed minus 4x squared. I think this will work fine. If it doesn't, I'll just cut it off. So, domain. Set the insides to be greater than or equal to 0. I feel like this one should work out. I think we'll see. I believe it should. Now I'm kind of worried. Let me actually think real quick here. Sorry, I know it's terrible. Yeah, that'll work out fine. Okay, cool. So we want to set x to the fourth minus 3x cubed minus 4x squared to be greater than or equal to 0. We're going to factor out an x squared first, because we can. Left with x squared minus 3x minus 4 greater than or equal to 0. And then we're going to factor this more. It does factor. The factors is x minus 4 times x plus 1. So the important numbers that are going to go on my number line are 0, 4, and -1. 0, so -1 on the left, 0 in the middle, 4 on the right. Pick a number larger than 4, like 5, plug it in. Positive, positive, positive. Pick a number between 0 and 4, like 1, positive, negative, positive. Pick a number between 0 and so like -1/2. -1/2 squared is still positive. -1/2 minus 4 is negative. -1/2 plus 1 is positive. So we have a positive, negative, positive, which is overall negative. And then finally, over on this other side, we have picked something like -2. So -2 squared is positive, negative, negative. So positive times negative is a positive overall. So here's the thing I want to point out. We do want the endpoints because we want it to be equal to 0. So we're going to include this endpoint, and this endpoint. We want all the positive parts, none of the negative parts. So be careful here. I want everything from -infinity to -1, bracket, union. I want this single point all by itself. I think in the homeworks, it's just written as a point all by itself. If you were actually writing the answer, you would write it as something with braces like that. Those are called braces or curly brackets. So just the singleton 0 all by itself. And then we want everything from 4 to infinity. So if you have just single points, they're kind of like islands in a sea of negativity here. If you have those single points all by themselves that are surrounded by negatives on both sides, you just include them by saying, well, we just want that one point. That's what I want to make sure I covered. All right, that's the end of part 1 for the homework number 10 video. Part 2 will cover more about range.